Welcome to the CAS-005 SecurityX lesson on supply chain management. In this video, we will explore how software and hardware supply chains impact cybersecurity and how proper validation, certification, and end-of-life planning help build resilient systems. Let's begin with the software supply chain. Software today is rarely built entirely from scratch. Developers depend on open-source libraries, third-party APIs, development tools, and automation platforms. While these speed up development, they also introduce potential risks. If even one of those components is vulnerable, outdated, or compromised, it can threaten the entire application. This is known as a supply chain risk. For example, imagine a web developer includes a popular JavaScript library to manage forms. That library later becomes compromised, and an attacker inserts malicious code. If the developer's application automatically pulls updates from the library's repository, the malicious code gets deployed to all users. To protect against software supply chain threats, developers should use tools like software composition analysis. These tools scan third-party components for known vulnerabilities. They also help teams create and manage a software bill of materials, which is a full list of software dependencies in a system. Additional safeguards include only using trusted package repositories, setting version controls to avoid unexpected updates, and placing security gates in continuous integration pipelines to prevent risky code from being deployed. Now, let's move to the hardware supply chain. Hardware supply chain management is about making sure that physical devices and components used in your environment are authentic, secure, and untampered. Cyber criminals and nation-state actors have been known to tamper with devices during manufacturing or shipment. Risks include counterfeit parts, malicious firmware, or backdoors installed in components before they even reach the customer. For example, a company purchases network switches from a third-party reseller. Unknown to them, the firmware on those switches has been modified to send data to an external server. The organization installed the devices in its core infrastructure, unknowingly allowing data to be siphoned off. To mitigate these risks, organizations should only purchase from trusted vendors. Vendors should provide detailed supply chain documentation, including the origin of components. Organizations can use tamper-evident packaging and track device custody from the manufacturer to the deployment site. Next, let's talk about hardware assurance, which includes certification and validation processes. Certification is the process of having hardware tested by independent labs to confirm it meets established security standards. Examples include FIPS 140-3 for cryptographic modules, and Common Criteria, which evaluates the security features of IT products. For instance, a government agency may require that all hardware used in its operations be certified under FIPS standards. This ensures that the cryptographic modules on routers, firewalls, and laptops are trusted. Validation, on the other hand, involves verifying that the hardware matches its documented specifications and functions as expected in a secure way. It ensures there are no undocumented features or vulnerabilities. Before deploying new laptops, an enterprise security team might validate the BIOS firmware, confirm secure boot settings, and test for signs of hardware tampering. They may also compare hash values of firmware images to detect unauthorized changes. These practices provide confidence that the hardware has not been altered during transit or production. Now, let's discuss end-of-life considerations. Every product has a lifecycle. End-of-life, or EOL, means the manufacturer will no longer provide updates, patches, or technical support for that product. Continuing to use end-of-life software or hardware creates major security risks. Vulnerabilities that are discovered after EOL will never be fixed, making those systems attractive targets for attackers. For example, a hospital continues to use a patient monitoring system that runs on an old operating system. That system is no longer supported by the vendor. A known vulnerability in the software is exploited by attackers, who then gain access to the hospital's internal network. To reduce these risks, organizations should track the lifecycle of all their assets. Before a product reaches end of life, plans should be made to upgrade, replace, or isolate the system. If immediate replacement is not possible, virtual patching or additional monitoring tools can be used temporarily. Keeping an accurate asset inventory and maintaining awareness of support timelines are key to staying ahead of end-of-life threats. Let's recap what we've covered. Software supply chains must be monitored to ensure that external code and dependencies are secure. Tools like software composition analysis and software bills of materials are essential for managing risk. Hardware supply chain threats can be reduced by sourcing from trusted vendors, using tamper-evident packaging, and validating hardware during and after delivery. Certification and validation offer assurance that the hardware meets security expectations and has not been altered. And finally, end-of-life planning ensures that unsupported software and hardware are phased out before they become liabilities. By managing supply chain security across software, hardware, and lifecycle stages, organizations can build systems that are more resilient, trustworthy, and secure. Thank you for watching the CAS-005 SecurityX video on supply chain management. Stay tuned for more lessons to help you prepare for your exam and strengthen your cybersecurity knowledge.